Doo-doo-doo-doo-doo-doo. Hey, it says we're going. Hey, we got sound. We got vision. Yeah, Rust project. Okay, a little story. Oh, welcome. Hello. A little story over Christmas. I got bored and thought, what shall I do next year? And maybe I should learn a new language. Well, not learn a new language. There's no such thing on computers these days. Well, most languages are basically the same. Until I thought about Rust. The Rust language. That's not the same, is it? I see. Rust, huh? What on earth would you want to do with Rust? Well, you download it, you stick it on your system, and then you can make projects. And you can learn the Rust programming language. It comes with a book, an online book, and it takes you through everything. Yeah. There's quite a bit to this book. Yeah. Okay, I think we might be skipping that. And I want to look at ECS, Entity Component Systems. So, let's go to https crates.io. Rust uses crates. Okay, ECS Rust. What's this one? One at the top. This'll do. ECS Rust. There we go. Oh, it's got an example. How to import dependencies. Okay. How to run desktop examples. Okay. WebAssembly. Oh, yeah. Yeah, what is that all about? What is this web garbage all about? Why are people making games on the web? Putting them on web pages? What a stupid idea. Right. Yeah, this looks alright. We've got some sample code. Alright, we'll do this then. Import ECS Rust. Okay. Seems to be quite a bit of it. World Entity Manager Component and System. Why does it need an entity manager and a world? Surely it should not need the top one if it's got the second one. Anyway, that's beside the point. So, crates. What are crates? Crates are equivalent to libraries. Libraries of functions and functionality. Okay. How do we make a project? Well, we're using the cargo system, which is cargo crates. Get it? Yeah, okay. So, don't really want to do that. Get you back to where you were. So, cargo. We want a new project. By the way, I've got no idea what I'm doing. We'll call it ECS Dev because we're learning. And anytime I'm learning something, I always underscore dev at the end or put a dev on it for development. So I can learn more about the subject matter and what I'm doing. There we go. Rust project, ECS dev, select folder. Wow, that worked. First thing I want is a file, please. Read me dot, it's MD, isn't it? Forget. There we go. And this is what we're using. And this is ECS Rust. There we go. So what is it giving us? Some source code, I hope. So let's have a look at that. Oh yeah, it's giving us print line, hello world. We'll change that. Welcome to ECS for Rust. There we go. That'll do. Now, I do have a run button here, but I'm not going to use it. We're going to use the terminal. So, what do we want? We want cargo run. We should build and run everything. Yeah? Yeah, there we go. Welcome to ECS for Rust. It worked. It worked. My God. Let's just quickly check the size of our typing. It looks clear enough on 1080p. Do we need to increase that anymore? Let's just have a look. We can increase it a bit more. That might be a bit clearer. I think if we go any bigger than that, it's going to start looking silly. Right, we'll try that for now. And there you go. We've got our experimental development program for ECSs in Rust. It's up and running and working. So, let's source control that. Commit. Master. There's the message. Changes. Add. Base setup. We haven't done the base setup yet. We need to add our ECS system, don't we? Let's do that, and this is where the fun starts. Alright, so we've got cargo. Add. Yeah, we can add our library now, and that is ECS. This comes from cargo.io. So, sorry, crates.io. So it actually comes from all of this stuff here. It looks in there for it. That's cute, isn't it? So you can find stuff before and look at it and everything else like that. So ECS Rust. There you go. One packages, adding ECS Rust version 0.0.4. Compatible version, yeah. Translating ECS Rust to ECS underscore Rust. Ah. Alright. We've got to build our library. So it compiled ECS Rust and ECS Dev. It's done everything. It's done all the compilations. Everything's up, running, and rather nice. Where did that go? I can't see. Thank you. This panel size is a bit big. Never mind. So, we've now got everything was set up there. Everything says base setup, changes. Yeah, we've got all of our changes. Make sure we have. We'll add that. 0 and 5. 5. Yeah, everything matches up. We'll just commit that. Get it out of the way with that. That's our base setup done. We've now got ECS. I usually try and commit stuff before I carry on. Because I might need to go back to it. As I'm learning, and it's a development thing, yeah, things are going to go wrong. Very wrong. Which is always funny. Okay. Awesome source. Doesn't seem to be too bad so far, does it? Well, one thing I don't like doing is, in main, making a file that's this long. Oh my god. No thank you. So, let's think about this. The one thing I've noticed whilst looking into Rust is that everybody seems to write in one file. And I thought to myself, why is that? And the only answer I come up with is that they're just coding. They're not programming, they're just coding. And that's what you do when you're coding. You just plonk everything into a file and hope for the best. So I'm not doing that. I want to program in Rust. I don't just want to do coding. I mean, I could copy all of this out and just paste it. That's no blooming good to me. I'm not learning anything if I do that. Right. We're going to have a new file then. We're going to call it ECS. Alright. We now have an ECS file. So if we've got an ECS file, we'll need to include it into this lot. Give ourselves a bit of space. That's mod ECS. And it's got squigglies. Ah. It needs to be an RS, a Rust file. So let's do that. Oh, that was interesting. It did summit. Yes, you can. Why can't you find it? ECS RS. I think it's lying to me. I just think it's lying to me. This is one of the problems with having these highlighting things on. I think it's because it's an empty file. There you go. You can find it. You were just being lazy. God, I hate lazy computers. Yeah. Visual Studio Code will lie to you. But I think it's better to have these things switched on. I've got them switched on using Even Better TOML and Rust Analyzer. I've installed these two just so that it gives me some kind of error output, which is very distracting and pretty goddamn useless at times, but it's there. We can ignore it. Right. What do we need? Well, I think we might need some of these use cases. Do we put them in? No. No, I'm not. I'll put them in as I need them. There's different ways you can do that. But you are supposed to know what you're doing, I guess. Who needs to know what they're doing? Yeah, that's right. So we'll leave some space for uses. Then we'll make a public struct. We'll call it ECS. Oh, wait a minute. I want capitals, don't I, for this? ECS. Yeah, why not? I'm not going to put anything in it. Okay. We can then implement it. ECS. There we go. Do I need anything else? Don't know. Okay, we'll implement an ECS. And we can write a public function, probably new. I'm not doing anything with it. Yes, I am. So we'll put, it's going to refer to itself, I guess. And it's just going to return self. SELF. Well, we're getting plenty of errors. That's always good. I'm guessing we'll have to return self. Missing type for function parameter Rust. Type? What do you mean type? There is no type for self. It's an ECS. That's interesting. We'll let it think about it for a second. Yeah, that sounds all right. You want some fields, do you? There you go, you can have some fields. How about that? Well, that's interesting. So how are we supposed to do these structures? Syntax error, missing type for function parameter. Tell you what. We'll do that. How about that? Suck on those eggs. Right, so it's reporting that I've got two problems, that these aren't being used. Now, you're not allowed to do that in Rust. That's interesting. So we need to use them, I guess. And we can use them in main, can't we? So we can set up a variable. We'll call it ECS. And we will go to our ECS file. And we'll make it an ECS. Do I need to do anything else with it? Don't know. Can we just do .new? No? Okay. Oh, wait a minute. Public function. Okay. Public. Okay. Is it that? It is. Use struct literal syntax instead of ECS. Okay, quick fix. Do that for me. Yeah, that's what I was thinking. Expected value. Ah, you want values, do you? Okay. Oh, I can see a problem already arising from this. Yeah. I don't like that. I don't like that at all. No, that's not what I want to happen. I don't want this. That's what it's giving me. I want this. So maybe I was right with you. Yeah, I think I'm happier with that. Why is everything going off the screen? Yeah, now it's telling me this isn't used. Yeah, that's fine. What I'll do then, for now, I'm just going to put an underscore on it. That just stops it from whinging at me, because we're not going to use it for a second. Right, just stop it from whinging at me. Okay. So we've created a new file. We've created a new ECS, which I'm going to use for initializing stuff here. So what I'm going to do is I'm going to keep these brackets as my initializer. I think that's probably a good idea. And we're going to put things in here to be kept and held as a global variable, I suppose. I think that's the best way of putting it for now. Alright, and I think that's doable. Yeah, it runs. It runs pretty fast. That's pretty... I like that, that's good. Yeah, it's pretty much... we can probably get a couple of extra lines in there. Yeah, lovely. And there we go. That's the basic setup and construct, I guess, in Rust for development purposes. So we set up a basic ECS file. We haven't actually done any programming yet, have you noticed? I mean, if I was programming in C or C++, it would probably take me longer to set this up. But it's roughly the same code. Roughly. But I don't think I'd have to worry about it as much. This inclusion of modules. Yeah. And the pathing to get through to it. Yeah, okay. We worked it out. We got there. Now remember, I only started looking at Rust, well, it was after Christmas. It was more like the New Year. All I've done is I've read up a bit and messed around with it a bit. And even now I'm uncertain about how it's going to function. I've picked up a bit of the syntax, I guess. But this isn't like most languages, is it? I mean, we've got something called a borrow checker to worry about. Well, you don't need to worry about a borrow checker if you're programming. If you're coding, you do. And you're going to run into a brick wall with that one. Trust me, I tried it out. I tried some coding and then tried turning some code into a program. And it ran into a brick wall of borrow checking. And I wonder why that is. Because when you're coding, you don't actually program correctly, is the answer. Right, so what's the first thing that we're going to need? According to this, let's have a look at the main program. Main, create world. Okay. I'm going to be cheeky. I'm going to put it in the new function. I'm going to use the new function to initialize everything. Yeah. You're not supposed to do that, are you? Are you? I don't know. So let's try that. It's going to be world new. Oh well, we've seen this already, haven't we? So they're doing it the same way that I've just done it. Okay. me do it. How? Oh no, good. Alright, we'll import it. And it says use ECS Rust world. Use ECS Rust world. Oh, it matches up. It did it automatically for me. How nice. W is not used. Yes, I know it's not used. Well, that's interesting. I didn't have to think about that too much, did I? And it tells me, it's giving me this. Okay. And it's telling me what type it is. I didn't type this. The Rust Analyzer has inserted that to let me know what type it is. That's handy. If I double click on it, it'll actually insert that into the, it'll type it in for me. Huh. Nice. But it's giving you a full output of it. It tells me it's got an entity manager, an entity ID accessor, a systems vector, go to definition, control plus click, nice. Double click to insert that part, yeah, okay. Quick fix. Oh, right, yeah, I'll just put an underscore in front of it. Which I don't want it to do, because I want to show you something. There is an extra thing here. Oh, wait a minute. Format document, please. Right, okay. Before I do this. We have cargo. Clippy. What this does is it will go through your files and tell you if there's things that you should consider changing. Well, things you should change. Look at all of that. So, if this isn't to prefix it with an underscore, but I didn't know about this. ECS contains a capitalized acronym. Consider making the acronym lowercase except the initial letter. So it should really be ECS. Right. Well, we can do that. We'll do our clippy things. So that's the one that's really bothering it. But this, I didn't know about that. So that should be ECS. So it helps you. That's a little amazing, isn't it? Main doesn't work now. ECS. Okay, everything's back to normal. There we go. Everything's absolutely hunky-dory. So you actually get hints on how to program. Doesn't do anything, but hey ho. Right. I find that interesting. Because I haven't experienced that before with other language. Well, I haven't experienced that much help with other languages before now. So, learning the language, it's designed in such a way that it wants you to learn the language. 10 out of 10 for effort. Right, so what we're going to do with W? Well, it's a colon world. So if I've got this right, we could put world here. And we'll need a world. There we go, it's got it. And we put a comma at the end if I remember rightly. Alright, this now highlights as being an error because we haven't defined it. We can take this off here now. So, world W. Is it a comma or a semicolon? I don't know, we'll put a comma. Yeah, it accepted that. So world is never used. Okay, tough. We'll get to that in a minute. But you can see how it's trying to say, hey, look, you've made this thing and you're not using it. What's going on? We haven't got that far. You know, one step at a time. So what I'm doing now is I'm storing our new world into an ECS structure, which I can then use to reference our world. Is that how you spell world? It is. What an ugly word. I'm dyslexic, so yeah, things look a bit strange to me. You might say that doesn't help with programming, but it actually does. It's always an interesting idea when you're trying to program and you can't read properly. But it makes things more interesting. Right, what do we do with our world? Do we do anything with it? We register components to world. Oh. Right, we're going to need components, everybody, in our ECS system. And this is where Rust took me down a bit of a rabbit hole. Because I don't want my components in here. Do I? No, I don't think I do. So I want my components in a different file. And I can't put them here. Because we're now inside ECS. Oh. We're going to need a subfolder for ECS now, aren't we? Yeah, so a new folder, we'll call it ECS. Alright. And in ECS, I'm going to put a file and we're going to call it components. Alright. And now in ECS, I can put mod components, which it can't find. Why can't you find that? That's interesting. It's just telling me unresolved module, can't find module file ECS/components.rs. Did I spell something wrong? ECS components.rs. Huh. No, it can't find it. Is it another one of these where it's just taking its time? Mod C, and it comes up with that automatically. It's not telling me that it's there. Alright, fine. We'll leave that then. So, under components, let's have a component. How do we do components? It's just a struct. Okay. That's a normal one, isn't it? There you go, position. That's going to have to be public. I'm very suspect about this. Module path, okay. Why doesn't it like any of this? I must be thinking about this wrong somehow. I wonder if he'll pick it up from here. No. Because it's not in the source folder. There we go. That's the answer. We need this subfolder inside of our source files. Gotcha. You horrible, horrible person. I put my folder in the wrong place. There it is. Components. So I can now use it. Huh. Now it's going to tell me this isn't being used. I know it's not being used. That's fine. Right. So how would we use that? Because we want to be able to add components. Well, I think that should come under here. But I don't want it just for one component. I want it for all components. Why are they adding them like this? Register components to world. Alright. So we can have a function that says register components. Okay. Public function register components. I think I want that under components. I don't think I want it under ECS. I don't know. It's probably going to have to take something in. I would say a reference to the world. No, it'll have to take in a reference to our ECS. So that would be a reference to no. It'll be ECS. I'm trying to get this the right way round first time, and it means I've got to think about it, and that's bad. If I have to start thinking about things, then we're in trouble. Yeah, that'll do it. You might have noticed it's picked it up, because this is a subfolder of ECS. So it's automatically picking this up. I don't have to start using things. Does that mean I can type in ecs.world now? It's going to have to be mutable, isn't it? Let's make that mutable. Yeah, we've got this thing where we've got to borrow and mutate and stuff. Is it colon? No, it's not. It's definitely a dot. W-O-R. Maybe we can't do that. Dot. Oh, it's doing something. But we can't register a component. Okay. Alright. Alright. I see how it is. That means we're going to have to probably use something. An entity manager, component, and system. I wonder where register component actually is. Hold on a minute. Implement, what's this all about? Why have we got to implement components and systems like this? I'm trying to break down their coding into something that's actually programmable. So I think I need to do that. Let's try it. Implement component. For position. All right. And then you've done that, and you haven't done anything else, so it's just an empty implementation. Alright. Anything else I've missed? It's not asking me for anything, is it? No. Oh, it's put it in. Now we're getting this. Import use super ECS. Alright. So it can find it. Nice. I'm just wondering why we need to put that in when it's part of the actual file system. Okay. We'll do it. Yeah, it's unused. Yeah, I know it is. Ba 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 ba. Alright, so we're getting somewhere with this. Alright. Let's try it out now. 1 second. Let's format our document. Maybe now we can actually start writing this line for register components. So if we've got an ECS, we should be able to dot it to... We can. And now we should be able to register it. Register component. Huh. Doesn't actually include it properly. We'll put in position. Like that. Huh. We'll save that out. Oh, it's not liking that. Oh dear. Oh dear. Use ... Yeah, that's right. We should, because I should be reading what it's telling me to do. Okay. Now, ECS World is a bit hard spoken by. Let's have a look at that. Cannot borrow ECS.world as mutable as it is behind a reference. Oh. Okay. No. As it is behind a reference. And this is the borrow checker. Okay. We'll take the reference away. Change to be mutable. Oh, alright, it just did what I did. Alright, okay, fair enough. Well, that's a problem. Isn't it? Because now ECS belongs to this. And when we get to this, it's going to kill my ECS. It's going to free up the memory and we'll no longer have it. I've got a feeling we're going to see that in action. And position isn't being used. It is, it's here. Oh, position is never constructed. Yeah, okay. Okay. I'm not here to construct it. Let's have a look back here. So I've got a feeling this is not really going to work properly, is it? So if I go to our components, and I now register the components, giving it the ECS, which is self. Is it just self? Yeah, it is. No, that's wrong. Why has it gone lowercase? Okay, it is self. Alright. Expected value found module self. It found the module. I've got a feeling that's because we need it in there. But that's still ECS. Is that correct? It's saying it is. Huh. Remember, the only 2 lines of code that were put in here is this, new. Takes 1 argument, but no arguments were supplied. This doesn't feel right. No, this doesn't feel right. No. We're not doing that. Because we haven't constructed it. We can't do that. Alright. That's not going to work. You see how it's forcing me to program? That's going to cause all kinds of problems. Okay, let's look here. We've got an ECS. Let's run it. So public function run. Now we're going to have to take in self. So is it going to be a reference? Yeah. Self. Alright. Does it have to return anything? Don't think so. So it will be self. Dot. Ah, yes, it's come up with world now. Run and world. That's good news. That's working. Alright. Might not be what I want though, is it? Should it be a capital? I don't know. This is the problem that I've got with this language is that's a capital S. ECS def ECS. Public struct. Blah blah. This is no. I think that's supposed to be a capital, you know. But it doesn't seem to like that. I see it needs the parameter at that point. Okay. Fine. When we run this, what I would like it to do is build the components. That'd be nice. So components, register components, and then we have that, so it's self, ECS, okay, and it doesn't like it. Expected ECS found and ECS. Oh, we've done something right then. Alright, put an and in front of it. No. And ECS. Oh. I could dereference it, but that would be dangerous. So it's actually telling me now that I've got the other side of this wrong, which is what I expected it to tell me. It's telling me that this should be and. Which causes problems here. You see, this is now happy. But it doesn't like this. Why? Cannot borrow ECS world as mutable as it is behind the AND reference. ECS is an AND reference. So the data it refers to cannot be borrowed as mutable. I'm not trying to borrow the data, am I? It's trying to alter world because we're registering a component on it. So it is world that is the problem. Well, that's very interesting. How do you solve that? Consider changing this to be mutable. Component 538. What's 538? Oh, right, there's. Huh? Remove this mute. Variable does not need to be mutable. But you've told me it does. So who's right here? Everything's contradicting itself, which means something's very, very wrong. Rust Analyzer can create the mod file for you too. Oh, can it? I didn't know that. I haven't got that far into it yet. But yeah, that sounds good. That'd be nice. Hell, I'll try that. Thank you. So we've got this borrow checker problem, which I don't really know how to solve because it's contradicting itself all over the place. This says I've got it right. This says I don't have it right. The variable's mutable, but this isn't. Can I just put a mutable in here? No. I wonder if we have to make that public. Maybe. Okay. Doesn't seem to help. Do we have to make it mutable? Ooh. Oh, that was a straight no. Alright, we can make that public, but we can't... Well, that... Okay, we won't do that then. Why would that need to be public if the struct's already public? So that we give access to world. Maybe that's a private member if we don't do that. It would be a private member, wouldn't it, of ECS? So only ECS can... And mute. You can access it if you are in a submodule. Yeah, that's what I'm thinking. So I don't think it needs to be public. I don't think that's where the problem lies. I think the problem lies elsewhere. And mute. So if I take the and off there and put it on here, this is what I mean about the syntax being a bit rough sometimes. Okay. And mute the type of what? Move and mute the type and mute. Oh. It's saying move it to the type. And mute. Okay. Oh, I see. I see. Okay. That gives me that, I guess. No? Expected and mute, found and Andy. Oh, we're back to that silly thing again. Okay. Expected mutable reference and mute ECS, found reference ECS. Was there a quick fix on that? Yeah. Well, you've just put an and there, you pillock. Okay. As it's not declared as mutable. Which bit? As it's not declared as mutable, can I? Yeah. Cannot borrow data in an and reference as mutable. Yeah, we know that. We keep telling us that. Okay, gives us some examples, which is good. Alright. It's good, isn't it? Make, run, take, and mute too. Got you. Try removing and mute here. Ta-da! Finally, we got through it. So the and mute, when it said the quick fix, put it in here. But it really should have put it in here. Wow. That's amazing. So did it do it wrong? Yeah, I agree with this. This now reads right. So we're getting past the borrow checker. This is starting to read right. So we're borrowing our memory correctly now. And it's a reference, so we're not passing over ownership. Fantastic. That makes me happier. Because remember at the beginning I was unhappy about ECS coming over. Because basically we're sending it over and it was going to kill it here. Well, now it won't. It'll kill the reference, the pointer, the reference to it here, which is what we want it to do. It's now doing it right, and I didn't need to mess about with this structure. So we're not using run. Okay. We'll do that then. ECS dot run. There we go. See if we're allowed to do that. Doesn't look like we are. That becomes a mutable reference, and I think we're okay. Yeah. So it's this mutation thing. Because we're altering data within inside of the ECS structure. So right, so we've got that running. We've got all of this in green. And now we're back to here. What's not being used? I don't see the problems. Oh, we still haven't got a structure. We've never really defined what this structure is. What those F32s are. Where should we do that, do you think? I like this borrow checker thingy. I don't think I'm hitting my head against a brick wall, but I mean chat here on Twitch has helped me out a little bit, and I think we got around it quite well there, because I'm not that experienced with this system yet. But it shows how easily you can get into a brick wall if you don't know enough about the language. And that's why Rust is different. The help system is good. I was going to give it 10 out of 10, but now I've got to drop it down to 8 out of 10. It didn't help me pass the brick wall. Twitch chat did that. I'll give a shout out to True Lagumo. Thank you. I don't normally do that, but thank you. You've saved me a big headache there. But we've now got a program. And it's working. We don't have a position yet. And And we shouldn't have a position. We only define our position when we give that component to an entity. Is that true? Or should we have a default position? I think we should have a default position. Because at this stage, but they're not setting defaults here. You see, they're setting the position when you add the component to the entity in the example stuff here. But I'm not overly happy with that. What happens if you forget? Or you think there's a default? Shouldn't you have a default? See, this is coding. This is what coding looks like. It looks bloody awful, and I hate it. This is programming, where we're actually trying to structure something that's expandable for the future, where I can just add more and more components, and I know how to do it because it's obvious. It's already here. And we can just add them on top of each other and then register them. So everything's in the same place. If you look at the coding, so you want to add a new component. Well, you've got to first of all find out where you put your components and add it here. Then you've got to implement them, which is all down here. Can that give defaults? It's not in the example, but it's a big question in my mind right now. Oh, cheers, True. People have a lot of difficulty with learning Rust because of the borrow checker, but it's a mindset. It's not a problem of the borrow checker. It's because people tend to do coding rather than programming. When you're doing structured programming, it's slightly different. It means that you're programming wrongly. If you're coding, it becomes irrelevant most of the time because you're usually within one file all the time. And when you hit the brick wall, it's probably easier to get out of. Can I put x colon 0.0 comma y colon 0.0? Am I allowed to do that? It just took it off here. It says they are being defined. I'm just doing it wrongly. Don't blame me if you mislead me. Oh, feel free. There is a default trait, and you can make your component trait inherit from that one. I'm tempted but I want to experiment with this a little bit. I'm trying to learn Rust, but I want to learn it from a naive point of view, even though I'm a programmer. I've used C and C++ for many years. I've used other languages. I've even used Rust in the past, but that was many moons ago when Rust was new. And it's changed since. It's looking for a colon colon. Why is it looking for a colon colon? Yeah, I'm trying not to add extra functions. Oh, wait a minute, this is an impl. Oh, got you. It's the penny's just dropped about what you're saying there, True. Thank you. Yeah, you can't do that. You'd have to have position or self. I'm going to try position. You can't have position in here. You'd have to have a function. You can put functions in here. You can't put that. I'd have to put it inside a function. So your idea of a default is probably better. Have they put anything at all on theirs? Structure enable, structure. No, they haven't. But what you're saying is hash derive, which doesn't do it like that. I think we have to open a bracket or something, don't we, for a derive? Can't remember. Default. Oh. Now it comes up with derive. Never done this before, so no idea how that works. I've never done a hash derive before. Core macros built in. Well, if you're built in, bloody use that. Wonder if it's not a hash. I think it's a hash derive. That's how the macro system works. Ah. Alright, let's try it. Getting a bit of help here from okay. Default. There it is. Still not liking derive. Yeah, expected that. Expected item found that, which is referring to this bracket. Not very helpful there. I know what we're going to do. hold the phone. Let's do something stupid. Because I actually don't know what I'm doing. And I just realised I actually don't know what I'm doing. And that's something you've got to realise when you're programming, is you've got to know when you don't know. So what we need is Rust manual, don't we? Really, we need a manual for Rust. Rust docs. Let's go with language. There we go. Let's learn it. Documentation, the standard library. Just actually, I'm gonna pop that in anyway. I think that might be useful. So this is a standard library. Modules, crates, std. Alright, let's go back to this. No, let's not. Let's look inside, read the book, check out Rust by example, read the book. Okay, we've got a book. We'll take that one as well. Because we can. So I've got a book. Structs. Oh, we see. We could have looked at that. Alright. We're searching for derive. Derivable traits, Appendix C. Appendix C. Yeah, have you got an example? Not there. Not there. Always equal. Yeah. It doesn't give you an example. Huh. Using structs, okay. So we've got a rectangle. Yeah. It's good, isn't it? Rust up doc opens the docs. Oh, cool. So that was... If I remember, it's... Wait a minute, you can use cargo. So you'd have cargo docs open. I think that works as well. Don't quote me on it. I'm going to put it in there. Right, so this is how they want me to write it. I knew there was bloody hash in there somewhere. You see, there we go. It's still saying it feels X and Y are never read. Oh, right, so now they're never read. They are now defined, but they're never read. So that sets these two variables to 0.0 automatically. I think we're going to keep that because that makes me feel better rather than the computer. Being a programmer, having things wandering around with null values, especially after writing in C for many years, is a bad idea. And I know it is. And if you have a look, it's gone to 2 implementations, so there is now a default. So I can call the default. Yeah. Which one is it? Capital D or small d? Interesting. Why have they done this? They've done it with self, they're doing it with default. I'll just tab on the first one. And it's saying, no, you can't do that. Okay. Can't do that either. Alright, I think it might be automatic then. We don't know because it hasn't told us. It generates an implementation of the trait default. It's a macro. Okay. Rust up doc. Let's just check this out. I think I might be right with this. Sorry, I've just popped something in. Cargo docs -- open. I just popped that on there and I haven't checked it. My bad. So if I use cargo docs -- open list, find a package to install docs with cargo. So no, that doesn't work. Doc. Alright. Let's call it doc. Yeah, that worked. But that gives me my cargo documentation. I haven't got any because I haven't put any in. So that is wrong. That's that. That gives the documentation for the current project. And you're saying rust up doc. Let's see what that does. Rust up. Okay. Rust up. Doc. I guess we'll show it. Is it open or show? Open. No, just doc then. Rust documentation. Oh. Gives you all the references and stuff. So Rust up doc gives you a reference page. Okay, so this is Rust documentation reference page is Rust up doc. Okay, that's good to know. I keep notes because I forget. I'm an old git and I forget a lot. So thank you for that. I think I'll close out for now. And we're back to normal. Right, okay. Interesting stuff. So we've got references. I suspect that has happened. But I don't know if it has or not. We'll see, we'll see. Does it automatically run the default when it... I don't think it does. Just going to pop in this default thing, you see if we've got any more information about it, because the default trait allows you to create a default value for a type. Deriving default implements the default function. The derive implementation of the default function calls the default function on each part of the type, meaning all fields or values in the type must also implement default to derive. Yeah, okay, I understand that. It says implements, right? That's just an impl. That's an implementation there. It says it calls it. The derived implementation of the default function calls the default function on each part of the type, meaning all fields or values. Yeah, well, they all have defaults, obviously. Part of the language. All right. Okay. I think I'm all right with that as it stands. Can we get back to here? Thank you. As it stands, I think that's okay. It seems to be calling the default implementation automatically, according to what I've just read. So that's what I'm going to go with. Unused import. Well, I didn't type that in. So don't import stuff automatically for me, thank you. That's an interesting side effect of using this extension. It's just... right, yeah, because I was messing around, wasn't I? And yeah, okay. Right, so we have a position. It's registered. we've got everything we need for a component. That's everything that we need for a component, except that we haven't used it. Yeah. Amazing. It wasn't as easy as I expected to put that together. I was expecting something slightly more straightforward. If I was coding, I would have come up with this. This is coding. Because I'm programming, I'm thinking of the future and how I want to use this in the future, and how I can stop it from breaking down. If I want to add more components, I now have a structured way of doing it. And that's important. That's very, very important. Basically, I can just copy this section here and make any component I want. Okay. And then I can just add it here as a single line to register it into the system that I've been given by ECS Rust, which is the crate that we imported. Lovely. And remember, I have no idea how to use this crate. All we've got is this one example. There's no documentation that I've been able to find for it, so we could always read the source code, I guess. I mean, that's usually a good idea. I'll probably end up doing that anyway for that ECS. If you want to write your own ECS, by the way, you're looking at around about 8,000 lines of code, which is why I'm using a crate. I don't like doing it this way. I prefer to write my own. But I thought I'd start with a simple crate that is available on crates.io. Yeah. So everything that we've got now in components.rs is expandable and growable. I should now document what I'm doing here to make it easy for me to refer back to this in future. We'll skip that part for now. Does the code speak for itself? Up to a point. Up to a point. So I think we'll leave our comments alone there. Now, going back here, we've now registered our components and everything's hunky-dory. It's in green. Look at that, it's in green. This is still yellow because we're not using the components. Entities. Now looking to... We've got a component. Create entities and add components. Oh dear. I want a player. What's the most important entity in any game or any application? Let's put it that way. It's the user of the application. That's the most important person there is. The application revolves around the user. Yeah, it's the only time when you're using a computer. Did you know that those people with big egos that say that the world revolves around them, when they use a computer, it actually does. Interesting. That was a side thought, wasn't it? So now we need a user. How are we going to create a user? A player. I like doing game programs, so we're going to have a player. And where should the player be? Well, the player is part of the ECS system. Okay. And the player is very special. And I mean very special. I've now got this... Oh, wait a minute. I can't put this in there, can I? Now we know that this is all working. I can't put it there. Can I? Huh? Holy moly, I can. But the world won't be added here. Bollocks. That has to come after that. Oh. Oh, now it's gone. No, that's not going to work. That is definitely not going to work. Because that's a return value. I can put it after. But then we've got this problem here, haven't we? Yes. Okay. No, I'm not going there. That's just asking for trouble. Programmatically, it doesn't work because we're creating the world. We haven't assigned it to the structure, and we're using that structure here. We can't use the structure before it's actually created. Right. Okay. Bad idea. Lovely. At least I sorted that out in my own mind. So now we've registered our components, we want to be able to create a player. I think we need a module for that. You said it would work. If I put in module player, quick fix. What? It does it for me? Wow. We've dealt with components for a minute. Oh, that's nice. I like that. Okay. What kind of thing do we want to put in though? I'm just going to put in a straightforward public function create its player. So let's call it player, and we'll call it create. Okay. And we're going to need this world thing again, aren't we? So we'll go back to what we've written before, and we'll just put that in. Seems to be what it's expecting of me. So now I should be able to say player. Oh no, let. Oh. Ah. I want to let player, this is how I want to write it, equals player create. Ah. I didn't have to put player in front of it. Why not? Has it put a use in here? It has. I don't want to use. Thank you. We should stop doing that. So it isn't. It's player create. There we go. But it's returning a function. I don't want that. Alright, we'll do that then. No. We're going to have to return something. And I think it's going to be an entity. An entity ID. I don't know what an entity ID is. Okay, we'll just note it in then. Entity ID for now, because I don't know what it is. And we'll see if we can create one. This looks straightforward. So it's let, we'll call it entity ID, why not? Entity ID equal, want an ECS, ECS dot world create entity. There it is. Right, so it's a U size. Now I know what it is, I can type it in. U size. Oh, right. Of course. We're going to have to return it, aren't we? Entity ID. There we go. So we can put that at the bottom. So now if we have a look under ECS, we're getting the U size. That is self. Okay. Player is not used, so we can just underscore that to get rid of that little error for a minute. That's green, that's good. That's green, wow. Components is still being horrible with me, okay. There we go. So we're setting up a function now that can create a player. Interesting. I'm just wondering whether I can use derived default again on... I don't think we can, because it's a world new. I don't want to at this stage. So we need some way of creating a player that isn't going to be too messy. So what we can do is just try and do what they've done, which is ECS world and then we're going to do dot add component to entity. Now we need the entity ID, which is put in, and the component, which we can do ourselves. Position. Oh my god, I can't see anything. Okay. Position. And it's being awkward with me, thank you. We'll have to use these curly brackets, won't we? Yeah, and now we put in X colon don't know. We'll put it at 0, 0 because we can. Actually, no. I'm going to, so that I know that it's not a default value. Y colon 11.0. So that I can differentiate between the two. Guessing we're going to need a semicolon or something. That's interesting. They're not using a semicolon here. Or are they? I can't tell. They are. Okay. It doesn't like that. Why not? It's private. There we go. This is exactly what I was thinking. Right, so components. Public yeah, these are private. So we're going to have to make these public. Okay. Now players is happy. That's awesome. I like that idea. And we can just add more components by adding more components. But now we need to alter two different files. We add the component here, and if it's for the player, we then need to go to the player and add the component here. That's awkward, isn't it? We can't make this automatic unless we had a structure saying player components. and then we just add to that player component. That defeats the whole object of an ECS system. Wait a minute, true set. Alright, when you don't define, yeah, if you don't define a return type, it'll just give like an empty nothingness back. Yeah, that makes sense. This line's a bit long. No, it's not that long. It's that long. Can we do anything with that? Probably. No, I mean 4K, so I don't normally see programs at this kind of thing. It's still telling me that never read. Now we've set them, but we've never read them. But we've now got the entity ID. So we now need to read them according to here. So let's print those out to there. Yeah, I think I've got an idea here. How do I want to go about that kind of idea? I think we're talking really about a debug, aren't we? So what I would do is a public function which is going to be destroyed at some time. It's in the player file. We'll call it a debug. Position. I think that's fair enough. And it's going to take in an entity ID. Alright, so we type in entity ID, because that's what I'm going to call it from now on, I guess. And that is a usize. Okay. How do we get to that entity? That's an interesting idea. You see, this is where the experimentation comes in with using somebody else's library. Add systems. We haven't got to systems yet. Well, this is a system, but it's a debug, useless thingy that gets thrown away. How do we access? Function update. Oh, right, yeah, okay. Alright, so I've got the entity ID. So I don't need to gain an entity ID. We don't need to iterate over. Right, we've got a manager. Borrow component. That uses the entity ID and we have to unwrap it. that sounds roughly what we're looking at. So if we let a position equal something, can we do it directly? Manager? No. Manager will be a use. Use ECS Rust Component Manager. Okay. Entity Manager, Entity Manager. And this is saying use ECS Rust Component Manager. Interesting. I will go Entity ID Accessor, Entity Manager. See, it's come up with this already, position and ECS. I don't want these in here. That's annoying. Alright, let's try this. See if it comes up with anything better. What I'll do is I'll be removing that and that from this file, and we'll be referencing them properly. Do I have manager now? Cast manager. No, we don't. Component manager we have. Rust component manager. Entity manager comes under entity manager, yeah. We already know that. You told us that before. But you're not telling us where manager is. And yet they're using it. Ah, it's being sent in, that's why. Bugger. There's a manager being sent into the update function. So it only works on a system if the system is registered. And the world update is called. It's coming from the world update manager. Huh. Interesting system development. I mean, it's for ease of use, obviously. But it sort of like cuts out the middleman. So I wonder if I can use a component manager. And it's put it in here. Entity Manager, Entity ID Accessor. Oh wow, it's put a lot in here. Alright. Alright. What can we do with a component manager? Hey, Elite B, hiya. Huh. Can I dot it? No, you can't dot that kind of thing. You always have to use colons on it. Borrow component. I want one. Yeah, I just want to borrow a component, please. I don't want to actually borrow it, do I? Yeah, go on then, we will. Has remove from into as any get type ID, has remove type ID. Okay, that's nice. Can I borrow a component? Option and unknown. And self-entity ID. Component manager unknown. I didn't want to see that. It looks like it's the right thing. We'd need a component manager. I don't like this. This isn't looking good. We'd have to set up a system to do it. I think that's the resulting conclusion. This ain't gonna work. So we have to turn that into a system. Wow. And that's a whole different kettle of fish, isn't it? So this just is the wrong way about this. We're just going about it the wrong way. Totally. That is never ever going to work in a month of Sundays. That's what I've just learned. You can't use this ECS system in that fashion. We can't just pry into an entity. Systems can, we can't. Is that good or bad? What am I trying to do? I'm trying to construct a usable ECS for, well, any application using it's somewhere in here, using something called ECS Rust from Cargo crates.io. It's a library. They call it a crate. And there's no documentation on it. It's just one example we've got. So I'm experimenting as I go along, seeing what I'm allowed to do and what I'm not allowed to do. And it looks as though we're going to need a system. We've got components, we've got a player. If I open up system now, I'm going to cheat. Sorry guys. I'm going to cheat. I don't care. what I'm going to do is a quick debug. So, debug. Please remove this code. I hate doing this, but, well, what the hell, why not? So what we're going to do is we're going to create a position. So, I don't know how position's going to work, you see. Position equal position. Do I need anything else? Don't think I do. No. Okay. It doesn't come up with anything, you see. It doesn't tell me what it is. Unknown, it says. Why doesn't that feel right? I'll check it out. I suspect you'll be able to do what you want. I'm finding it tricky to use because there's no documentation, so I can't really look at things. But I'm also very new to Rust, so I'm also struggling with the language at the same time, which is fine. Can I just print that out? What would we do? Are we supposed to unwrap this kind of stuff or not? Don't know. These are questions which I can't answer straight off. Yeah, it's telling me now that this isn't going to happen. Oh, gotcha. It wants me to put some values in. That's fine. Right, it doesn't like that. Okay, X. It's interesting. Position is a type. No, it's not really. It's a structure. Or is it a type? That's what I'm trying to work out, really, at this point in time. So you're trying to assign a type to a value, yeah. Exactly. 10.0, because I don't want default values. Y. We'll give it some values. We'll be good. We'll try and do it properly. Now position. It's going to be a. Yeah. Yeah. All right, that works. So we're going to need two of these, aren't we? I don't think I have to do it this way either, but I am doing. Position.y. That, according to me, should work. Huh. Okay. I'm going to put an extra space return in there as well, just so it doesn't clutter my window up as much. Now everything's green. We have a complete program. These are being accessed. It's happy about that because we're accessing them here. even though it's debug code, doesn't matter. I'm interested to see what they think about my program. They say my program is correct. Really? Position 1011, that's correct. So according to everything that I've done so far, I have correctly programmed in Rust an ECS, but we've had to put a debug in to stop warnings. I can remove this debug and just put an underscore in front of each of these. But I wanted to see how to use the print and how to use the position type of thing. This gives me an idea of how this can be used. And that's probably more important going down the road than it is to actually just put an underscore here. So we can access the position using position.x and position.y. This is actually not too bad a language so far, even though we're using somebody else's library that won't allow me direct access to this. So we can move on to systems now. We've got our ECS, we've got our player, we've got our components. So we've got the EC, we just need the S. Where do we put the systems? Well, the systems are at the top layer. Components are the bottom layer, players are the second layer, systems. You see, it should really be called SEC, shouldn't it? Not ECS. Because your systems are at the top layer. Your systems rely on your entities, which rely on your components. Beats me why they named it ECS, but there we go. So yeah, that is now a structured program. Well, I'm debating whether it's a properly structured program or not. But yeah, I'll give you an idea what I mean by that. If I just reduce that a second. Don't know if you're going to be able to see this or not. Not very well. But under C++, I was messing around with trying to look at the ECS system. So the ECS system came in with game entities, then going down into the next folder, we had components, a components folder, an entity folder, and a systems folder with the different CCP and header files in. And that was actually, it might be better under this one. Yeah, I've got rid of that tab. So it was a main game ECS with the ECS splitting off into a flat system for structure. Is that what's happening here? We've got our ECS going into components and players. It seems to be flattening into files. These are directories that I'm showing on this. So this is a directory. You have a game directory, an ECS directory, component directory, and yeah, It's not doing that, but it's close. It's close enough for me to say that the architecture side of Rust is working. I mean, do I really need a player.rs? Probably not. That might turn into entity.rs. And then player would go down off entity into its own. Yeah, I can see how, yeah, I think those are going to go down into, yeah, the structure does work. It does work. I just don't like files with like over 1,000 lines of code in them. I like files with 100 lines of code in them. There's big reasons for that. But it also makes it a bit more difficult, as we just realised. Especially with the way this is now looking, with players having components. This add component to entity, yeah. It's not as... What are you doing, computer? Right. We've got this, and we've got our components now in a separate file. To make any alterations, we now have to alter things in 2 separate files. That's a problem. It really is a problem. And this is why I wanted to look more at the structure of this language and how it's going to influence the architecture. Because we can't really put the player stuff in the components. So I don't under ECS you're gonna run into this problem. Okay. I think that's fine. But we've got a fully working program with players and components. Nice. So, gone from base setup to an EC, no S. So, player and components. Basic. Because it's not finished. Well, the components is finished. Well, for now. Player is finished for now. We just need a system. Oh, okay. So this is just what creates player with a component. And that's complete. Nice. So we've actually completed a program without systems. I think I'm okay with that. GitHub having issues. Oh, I don't use GitHub on this because it's not for release. It's for learning and developing my skills at using Rust rather than anything useful. I mean, it's called ECS Dev. So I'm developing my skills in using just a crate and Rust. And I'm learning Rust as we go. I'm liking what I'm seeing as well. It's stopping me from making big mistakes. And yeah. While trying to read the source of the ECS library, you just add it. I've never come across that before. I just use cargo add ECS and it's underscore Rust. I found out. It told me. I think that's correct. Oh no, it says ECS hyphen Rust here. I'll use a hyphen then, a minus sign. Huh. I don't know who's lying to me sometimes with these computer outputs and debug messages you get. There's an absolute huge problem looming on the horizon, and I don't think anybody's thought about it. I'm going to ask a question now. When we come to file input and output and want to save the player, or this player's state, when exiting our application, so that we have persistence within the application of where the player is, what they have, like equipment, or if it's a role-playing game, if they have equipment, if they have a bank, storage with items in it, money, statistics, skills. You can see that they all can be added now through components, making it very easy to make this player. What happens when you save the game or save the player out to a file? Where's the data that you're going to save? How many components are you going to have? Well, I just mentioned a few. You're going to have about 20 components, maybe 30, just on the player. There's a lot of ways to go about it. The Surdy crate seems to be the most common for serializing. Yeah, you've got your serialization and deserialization. Yeah, that's correct. Then you just write the serialized data to the disk. Yeah, that's exactly what you do. You change everything to strings, or make sure everything's in strings, and then just dump your strings out onto a text file, or if you want to use a text file. But how many lines of code just to save your data out? C++. Let's just get into this a minute. Is 1, 2, 3, 4, 5 lines of code. How many lines of code am I going to produce for one component? There it is in C++. Well, C, I suppose. How do we do that? This is only doing player position, and that's all I'm doing at the moment in this experiment with the ECS. Remembering what we've seen already, this has to become a system. So our experimentation today has already told me that this has to be a system. Couple of lines. The numbers, remember? They are F32s, I think, currently. Yep, F32s. I've done that on purpose. I'm using position as my test component on purpose because it's got F32s in it. And we're going to save that. We have to have a way of saving it. Now we could just use numbers. Write to numbers. I think that might exist. It'll be in the file system if it is, under the standard crate. But once you start adding so this is only accessing the component sprite. I know it's a component because it's got a big C in front of it, and that's how I denote them. That's how I note them as a component, which I haven't followed yet. We should do that. And this obviously suffers from the same kind of idea. I'd have to pass each component in, well, a vector of components, I guess, into this function, and then pull out the data and do a file out for each component. So the number of lines is 1 per component. So if you have 40 components, we've got 40 lines of code. Probably something to access a vector. So about 40 to 50 lines of code. You can't do that in Rust. It's going to be, let's say, for 50 components, you've got 5 lines of code for each component. That's 250 lines of code already that we've got to write or functionalize in some way. Can you see me problem? ECS is actually causing an issue. As we are going to have to, as you said, serialize each component individually and then write it out to the file. Component position entity ID unwrap, something like this. Yeah. Yep. And that's with that as you say. Yeah. I completely. I like that, Ellie. But we're only dealing with one component, and a player is going to have a lot more than just a position. I think we are going to be able to minimize the lines of code, probably below 250. Using functionalization, we can probably get it down to about 100 to 150. Still a lot of code, isn't it? Do believe be able to serialize all the components at the same time. Now that's a blooming good idea. If we could have a serialize function. Get all the code into a vector and then pass the vector into a save player, and the save player just dumps it all into a text file. Yeah. I feel that that is probably going to be the way to go, and then experiment with that and develop that into a final solution that is very usable. I think that's probably the initial way to go. So we do have a way of doing it. Maybe not overly efficient way of doing it, but a way of doing it. It could become efficient eventually. That's interesting. I just had a thought. Let me just pop this back up a minute. File, open. No. View? Nah, I don't like these menus. Visual Studio, why are you so awkward at times? I do have a thing here, don't I? LS maybe? Yeah, that works. Oh god, I got to find it, have I? So I've got an X64. We'll look at debug. Here we go. 425 kilobytes in size for C++. And this is doing a lot more. It's got SFML in there. So it's got more libraries. Or a bigger library. 425 kilobytes. Alright. Target debug. We're at 260 kilobytes already. That's not bad. That is actually not too bad. 260,000 lines of code roughly, divided by, we're in X64, so it's 8, isn't it? It's a lot of code. There's quite a bit of bloat going on already. Okay. That's alright. We haven't opened a window. Oh my god. Can't imagine. How big that's going to cause this program to go. It's going to go into megabytes, isn't it? Yikes. Okay. So we're now discussing the problems of the future, which is what I'm thinking about when I'm programming this. So when you ask me what you're trying to do or what you're trying to to achieve with programming a development situation, you're trying to address things that you're going to come up with in real life applications. And then you're going to try and find solutions in a development environment, so you can play around with it, basically. In a development environment, you're playing around with the code, and you're seeing what won't work, what can work, what really makes a mess, what makes your file bloat up to 10 to 20 megabytes. Like, I'll give you an idea what I mean. And it was something that I noticed whilst messing around with something called Bevy Crate, the Bevy Crate. Projects, please. I'm still doing the Rust book. Do we have a Bevy Crate? Yes, we do. We do still have a Bevy Crate. So still got this. Spaceship plugin, movement plugin, all of this kind of stuff. Rust source file, okay. Alright, we haven't opened it. Okay. Why don't you show me what I'm after? Huh. Why doesn't it show me? Windows, why don't you show me what's in the project when I ask you to? Target. Debug, because I'm not clicking on the right. Yeah, 75,160 kilobytes. Hold on a minute, that's a lot of kilobytes. I can't cargo run it from here. And it doesn't do much. In fact, it does nothing. It opens a window and just does a debug printout of position. So a blank window and a debug of position. Huh. Bevy is a full game engine though. Yeah, but why is it compiling a full game engine into my code when I'm not using it? That's the question. I have managed to work out how to circumnavigate some of that stuff within the TOML here with the dependencies thing. You put dot and then whatever dependency, you give it a version and then you tell it what you want it to actually compile into your main executable. But there's still large bits and pieces that you're throwing in there that can bloat your executable if you're not careful. So there is that way around it. It is possible. But it is something I'm aware of whilst I'm doing like these dev sessions, is I don't attempt to do anything like that in a development environment. I'll just throw a crate in and let me executable explode, as it were, and see what kind of mess we've got and how to fix the mess. No, debug is just for messing around in. A release mode will be completely different, and you can alter how it constructs and what it puts into a release mode even better than you can with a debug mode. So your file size will reduce, so that this will give me the maximum file size to be expected. And then what I could do afterwards is work on a release mode that well, reduces that file size down to something reasonable. So yeah, file size issues. If you're not aware of it, that's another problem that you got to be aware of. That you could go into gigabytes quite happily without even being aware that you're doing that. If you're on, let's say, a smaller machine, you've got other problems. Because I'm already using 10.8 gigabytes of my RAM. And I've got 32 gigabytes of RAM. I'm using a third of my RAM already. My system memory. Yeah, about that. Now, I agree, 5.5 to 6 gigabytes of that is going to be Windows 11, because Windows 11 is very inefficient. And then, of course, on top of that, we've got VS Code, which is very inefficient. And on top of that, we've got Edge, which is bloody useless and inefficient. And then on top of that, we're going to have our code running. And we're in debug mode, which has a stack limitation. I think it's about 4 megabytes stack limitation. Are we going to be causing ourselves a problem as we develop serious applications? Well, possibly, yeah. We might get to the stage where we can't actually compile debug mode. We have to go to release. And then we have to start thinking about reducing the size of our debug. I think you can see where I'm coming from. There's hidden problems with all of this. And it's not just Rust. I'm not talking about Rust. All of those problems exist in other languages. I just believe that they hide them more. With this, it's damned obvious. Because I can see it happening. Whereas with C++, you can't exactly see it happening. But it's still the same thing. It's still the same problem. I know there's incremental building on C++. I think we're doing incremental building, so we should be okay. Yeah, we are. Yeah, going back in memory, yeah. It's not rebuilding every single time I press run, is it? No, it's not. It's just doing it. There's no build there. That's incremental building. Yeah. I think this language is good. It's stopping me from doing bad things. I think we've got problems down the road which need to be overcome. We've got hurdles along the route. You do with every language. I mean, most famous of all is C. You've got memory management. That's a big hurdle. Well, no, it's Mount Everest. It's not a hurdle. But once you overcome that, it's fine. You just got to climb that learning curve. And the same with C++, really. Once you get to the top of Mount Everest, you've then got another Mount Everest to climb for templating and God knows what. But that's a different story with C++. It shouldn't have never been introduced, but hey-ho. So, this language is taking me down a path which I appreciate. Have I banged my head against the borrow checker? Yeah, we did today. But it made me alter what I was doing. And I think now we're in a position where we can start on systems. I think that's where we'll go to next. We might have something here. We might have an ECS system that could work. And remember, I've chosen this at random. I haven't sat down and researched ECS systems available to Rust. There's a good 50 or so of them. If you want to spend time researching them, go ahead. I just typed in 2 words and picked the first one. Whether it's any good or not, no idea, don't really care. If I wanted a good ECS system, one that I understood perfectly, I'd write my own. To be honest with you, I wouldn't rely on a crate. I would write my own. And then this would be a lot bigger files. But that's beside the point. So where are we up to? We are up to... So we have an entity. So we now have... Let's go over here. We have the player entity. No, we'll do it here. So I've completed that. Not sure what I want to do with it yet. And we do have a position component. Yeah, that went badly, didn't it? My hand started shaking halfway through that. So that's what we've achieved. I think for one day that's good enough. I think we've got a save there, and I'm happy with the code that it's come up with. Are there better ways of doing this? Absolutely. But our code really isn't that bad. How do I do this? Control-0. It's 24 lines of ECS. Our player fits within 10 lines. Our component fits within 20 lines. I'm happy with that kind of structure. I'm not sure about this use super business that's going on. Don't mind that. I'm not happy with that, but yeah, I'll sort that out separately. And we've got a super ECS here. I'm not sure why it's doing that. It's doing it for this structure. Okay. Should we pass the structure down to somewhere else is one of the questions. But I'm happy with the way it looks, and of course our main program fits on the screen, and that's how main programs should look. And we have quite a lot now here. So we've actually developed our references as well. There you go, fully functional program. If you watch this video from the start, you've got roughly about 2 hours worth of video now to go through and have a look at how I started with an empty project and built it. I think in the next episode we'll probably do the system. See what... I don't think that's going to cause us too many problems. And we'll start looking at file input-output, obviously, because we want to be able to save things. God, that's going to be fun, isn't it? No idea how to do that. Yeah, I like the language. It's done well. It's done well to give us this, which to me is programmatically more correct than I would have thought. I was thinking initially, I'm just gonna make a mess. It didn't allow me to do that. Cool beans. On that note, I'm going to love you and leave you. I want some food, so let's say thank you to Ellie and everybody else that's popped by. I do realise people are joining this as viewers, and true, yeah. It's an interesting way of programming because I'm not coding. I'm not just running down a file and coding it and making a mess, which is what coding does. I'm actually trying to program. So hopefully this will open people's eyes up on how you can program in Rust rather than just open main RS and just code a load of rubbish into it and come up with a load of rubbish. Yeah, you might get a working program at the end of it, but what happens when you come back to it in 5 years' time and you want it to do something different? Yeah. This code that I've generated today can be placed into any application and modified with very little effort to do what you want it to do. That's the whole point of doing it programmatically rather than codingly, I'm going to call it. That's the difference between coding and programming. There you go, quick lesson. Interesting. Hopefully people start taking this up, and when they're doing other videos showing Rust, or any other language in fact, they'll stop doing this and start doing this. Breaking your problems down into sections and programming them so they're useful in other applications. This is obviously a sample, an example. So I'm not going to criticize the sample code because that's all I've got to work with. But it's interesting. Take care, peeps. And thanks for popping by. I'll pop this onto my YouTube channel, actually. I think that's a successful session. All right. Catch you soon.